Assalamualaikum and good day. Today we're going to continue our analysis how to determine the thrust N and shear force S at any point on our symmetrical or unsymmetrical of our two-pin arch. Take this for an example. At any point on our arch, for example at point here we call as C, we know at that point we're gonna have moment, we're gonna have HC, and we're gonna have VC. And at point C, we know the distance of X, and also we know distance of Y. And when we analyze our arch, we know we're gonna have a reaction at support A and at support B. Now we cut exactly at the location C. We know we're gonna have horizontal force at C, vertical force at C, and as usual we know reaction at support A, V, and HA. By using static equilibrium equation, we can find what is our HA and HC. So we take summation force x direction equal to 0, positive to the right, so HA minus HC equal to 0, therefore HA equal to HC. Then we take summation Fy equal to 0, positive upward, VA minus VC minus force of P equal to 0. Then we have our VC equal to VA minus P. Then we take summation moment at C equal to 0, positive clockwise, so M plus HA times Y plus P X minus A minus VA times by X equal to 0. Then we have equation for M, VA X minus HAY minus PX divided by A. So this is how to solve our problem of two-pin arch at any point of location C on our arch. Now at any point C on our arch, for example we take here, HC and VC can be reinstated with thrust N and shear force. Just you can see here, N and S at any point C. We take out that point C here, and our N the thrust N acting at alpha angle on point C. Refresh back your engineering mechanics. We know if we have a force at certain angle, we can resolve that into Fx direction and Fy direction. That means your Fx is F cos theta, your Fy is F sin theta. So back to your thrust and shear force, you need to use the same concept to resolve your N. By resolve your N, you can get your HC and VC. Don't forget, at any point C on your arch, we're gonna have thrust N and shear force S. So this is S. By knowing the alpha angles, we can resolve S and N accordingly based on the angle given. For our case here, the angle given here is alpha. So here alpha, here also alpha. This is axis for our N. This is also HC. Since we know the angle, we can resolve that HC on this axis. So we get HC cos alpha, and also we can resolve our HC on that axis, or we're gonna have HC sine alpha. Then we also can resolve our VC. The resolved force on this axis, the value for that is VC cos alpha. And also another force on this axis, we have VC sine alpha. Now from that, we can get what is the value for our N and what is the value of our S. So our N is HC cos alpha plus VC sine alpha. That's value for N. For our S, this is axis for our S. So the value for S is negative HC, because that against the direction of S. Negative HC sine alpha plus VC cos alpha. So this is the formula how we get from our case. So you have to remember this formula and you know how we govern that. And bear in mind, our alpha is dy dx in radian. We're gonna see the example in next case. For the case 3, we need to determine